So this video is on classes, and before I talk about classes, let's just talk about object-oriented programming. And I'm not going to go super deep into object-oriented programming, um, but I will discuss what the fundamentals of object-oriented programming is. All right, so the fundamentals of object-oriented is encapsulation. There's also inheritance. We also have polymorphism. And the last one is abstraction. All right, and in this video, we're actually just going to talk about encapsulation, and I may briefly discuss inheritance. I will just give a little overview of what each are. So encapsulation is pretty much being able to hide stuff from a user that they don't really need to see, right? It's kind of just like if we're driving a car, I don't need to know how the engine works and what's inside the engine and what makes the car go. Only thing that I care about is that when I turn the key and I press the gas, that the car goes, right? And if I press the brake, that it stops. How it works, I don't really care about that, right? Some people probably do, but I would say probably most people don't really care. The only thing they care about is that it works, and so that goes the same with programming. We've talked about this with functions. When someone uses a function, they don't really care how the algorithm is able to get the output. Only thing they care about is that when they give an input to the function, that it gives the correct output. So that's kind of what encapsulation is. And with encapsulation, we have different types of access that we can assign to our class. We have public, which pretty much means that these are going to be member variables or member functions that anyone could use. If anyone's using our class, then they have a set of member variables and a set of member functions that they can use with the object that we create from the class. There's also protected. And protected actually involves inheritance. If we inherit, if our class is derived from another class, then the derived class, right, the child class, is allowed to use member variables and member functions that have protected access, but no one else will be able to use it. So I can't go in my int main and try to use protected functions or member variables. And then there's private, right? And private is pretty much is similar to protected, but private means no one except for the class can use these member variables and member functions. That includes children of the class. If it inherits from another class, the children are still not allowed to use private variables. And I can't use these variables or member functions inside of my int main, right? I can't use it inside of my program. Inheritance is pretty much if we see a class that has a lot of the qualities that we want in our class, but maybe not all of them, then what we could do is we can inherit those functionalities, and then we can build our class based off of the functionality that already exists in the parent class, right? So it's a child-parent relationship. So if I have a class, let's say we have let's say like our string class, and if I wanted to make a class that will automatically put a period at the end of every string that is created, then I can inherit the string class and then I can build onto my class so that it adds that period. Um, Again, like I said, we're not going to really go into inheritance much. We're definitely not going to go into polymorphism. Basically, polymorphism is when we create a class, um, that will be parents of other classes. Polymorphism will allow the other classes to perform the same task differently. For example, if I had a class called shape and I wanted to calculate the area of a shape, that's done differently, right? So if I had a function called area and I wanted to get the area of a shape that's a type rectangle, that's different from getting the area of a shape that is of type circle. So polymorphism will allow us to define what the area means, right? Because it's different for every shape. Well, for not every shape, but for a lot of different shapes, calculating the area is different. Again, I said I'm not going to go into this, so if anything I said right now doesn't make any sense, that's totally fine because you don't have to worry about that right now. And abstraction, I'm not going to even confuse you anymore about abstraction, so we're not going to talk about that. But let's talk about encapsulation. Well, before we even talk about encapsulation, let's just talk about, uh, you know, let's just talk about objects in general, right? So when we create classes so that we can, so that we can instantiate an object of that class and then use the features that that class offers for the object, right? So let's just think about an object. So let's think about a cup, right? So say we have a cup, right? A cup is an object, right? And what we do with a cup is really limited by our imagination, right? When the manufacturers create a cup, most likely they create the cup so that you can put some liquid inside the cup, and then that you can drink liquid from the cup. That's usually the general use for a cup, and that's usually why a cup is developed, right? So when we develop our objects, we want to give all the characteristics and all the attributes, right, that our object has. So, for instance, if we had a class called cup, some attributes that we have for a cup is, maybe the material it's made out of. Maybe we have, the volume, how much liquid we can actually, the cup can actually hold. Maybe we have, a color for the cup. So, we can just start thinking about the different attributes that we have for a cup. And then we give that class those attributes so that when we create an object of that type of class, then that object actually has those attributes, and we can start manipulating those attributes for our object. And like I said, it's really limited by our imagination, right? Because even though a cup is used to, it's designed to put liquid in it, it doesn't mean that we can't create a cup, to play beer pong or something, right? Maybe we want to use the cup so that we can start throwing ping pongs inside of it, right? Maybe we want to use a cup to, turn it upside down. Maybe we want to turn our cup upside down and we want to put something on top of it so that it elevates. Maybe we put our laptop. I don't recommend anyone putting their laptop on a cup, but maybe we need to elevate our laptop, and so we look at a cup and it seems like it's the best thing to do. Was a cup designed to hold a laptop? Absolutely not. Are you going to go on Amazon and look up laptop holders and then they're going to show you a bunch of options for a cup? Absolutely not. But it is our imagination that says, hey, I need to elevate my laptop, and a cup is the best thing that I can see to do so, right? Not the best example, but This is just want to show how it's limited to our imagination. Let's think about a chair, right? Maybe a chair. So if I have a chair, and I'm a terrible artist, but let's say this is our chair. Our chair is designed for someone to sit, right? That is the main purpose of the manufacturer creating a chair. But how many times have you needed to maybe unscrew a light bulb and you didn't have a ladder or you didn't have a stepping stool? And so you said, hey, you know what? This chair might be the best thing so that I can actually reach the light bulb, right? The chair wasn't designed for you to climb and stand up. It was designed for you to sit on. But our imagination sees the attributes, right? All the qualities that this chair has, and it allows us to get the good idea that we could use this chair to satisfy our needs to unscrew a light bulb, right? And again, I'm not gonna go to a furniture store or let's say Home Depot, sorry, and say, hey, I'm looking for a ladder, and they're not gonna say, hey, well, why don't you come and take a look at our chairs? Our chairs are really, we have some really nice chairs, right? We don't want to, what I'm getting at is we don't want to start thinking about the uses of our object and start embedding things that don't make sense for our object. There would be no reason for me to put ladder attributes inside of my chair because I know that someone is gonna use it as a chair, right? That won't make sense. It wouldn't make sense for me to maybe put an extension on top, right, so that you can climb up and reach higher things, right? One that's not a really good design. You're gonna fall and probably break a neck. But so it's really hard for us to not do that. A lot of times when we're developing our objects, we think about the use of the object and then we start adding things that don't belong there, right? Leave that up to the developer's imagination. If they see, if your object has the qualities of what it is, then the developer can use their imagination and see that your object will fulfill their needs, right? And so we don't want to do vice versa of that, right? For instance, let's go back to our cup example. We drink from a cup, right? But does it make sense for us to put some type of function, right? Some type of function inside of our cup to drink? And that's a tough one. Does it make sense? And in my opinion, no, it doesn't make sense, right? Because does a cup drink? A cup does not drink, right? A human or an animal will get a cup and they will drink from it, right? So this is an attribute of a person, right? A drinker, maybe, right? If we have a drinker, then a drinker needs a cup, and then they need to have the functionality to be able to drink, not having the cup drink. So let's talk about how we will write our classes. So we use the keyword class, and that's all lowercase. And then we give the name of our class, right? So let's just use let's use vehicle for an example, right? So if I have a vehicle, you know, some attributes that we have for a vehicle, would maybe be, let's say that we assume that all vehicles have wheels, right? But we can't necessarily assume that they all have four wheels, right? Because a motorcycle is a vehicle and it only has two wheels, right? So if we wanted to create wheels, we may want to make wheels public, right? So when someone is creating their vehicle, they actually have access to the wheels and then they can indicate how many wheels their vehicle has, right? So maybe we will create, a string, or, maybe if we're just talking about the number of wheels, maybe we can make that an integer and we can say integer wheels. We can also, a vehicle usually has an engine, right? So let's say we make that a string, and then this can indicate what kind of engine they have. You know, maybe like a V4, a V6, a V8, or whatever, right? Um, you know, some vehicles have doors, some don't, right? So maybe we can have another variable so that you can state how many doors your vehicle has. And now let's think about functionality. What can a vehicle do? Usually you can start the engine, right? So we'll create a function called start engine. And a lot of times with vehicles, if your vehicle is going to move, then you want a way to make the vehicle stop. So let's create a function called brake. Okay, so these are functionalities that you would do for a vehicle. Now, do I put a function called drive? Well, I don't think that a vehicle, unless it's one of the self-driving vehicles, but let's assume it's not. Usually the vehicle doesn't drive. Usually a person drives the vehicle, right? So having a function called drive wouldn't really make sense for a vehicle class. Perhaps we can create another class called driver, and in that class, we can create a variable of type vehicle, and then we create a function called drive, and in that function called drive, we would have it start the engine, and then we'll probably have it, rev engine or something, right? That would be in a separate class, right? That would be in our driver class that can actually drive a vehicle. So these are examples of things that we have for a vehicle, right? These are public stuff. These are things that maybe our users would use, right? They will want to change the wheels. They'll probably want to define what the engine is. They want to start the engine. They definitely want to break the engine. So we can make those public. But let's say, now when we rev an engine, and I don't know much about cars, so I might be making some stuff up right now, but when we rev an engine, we we actually have to put gas inside of the carburetor is what I believe. If it's not the carburetor, please correct me. I don't know anything about engines, but the gas goes somewhere, right? Um, does a user need to use that function? Right, and just think about it. When I have a car, do I actually have to go lift up the hood and then literally put gas inside of the carburetor to make the engine run? Right, I don't usually do that. That's something that the vehicle does itself. That's something that the vehicle probably doesn't want the user messing with, right? Because if the user does it wrong, it could probably cause a lot of damage to the car, right? So we'll make something like that private. Right, we'll make that private, and we'll have a function that says, gas to carburetor. Again, I don't know anything about cars. That probably makes no sense. But I hope you understand the example I'm giving. Another thing that we might want to do, when you start the engine, the spark plugs need to give a little spark, right? I don't need to lift up the hood and do anything to the spark plugs to make them give the spark so that the engine can start, right? So that would probably be something that we don't want users to touch, right? So let's just say spark, right? So these would be things that are inside the class that would be hidden, right? And so that means that when a user is trying to use your class, right? If they're trying to use your class, then they can go into int main, and they'll now create a object of that class. And as soon as you create an object, right, now you've actually created what's called an abstract data type, right? And that means that this is not a data type that comes with C++, right? This is data type that came from your imagination, right? This is something that C++ knows nothing about until you compile your program, right? But it's still a data type. So I still can declare a variable of that new data type as I would any of the primitive data types, right? For example, we have integer x equals 0, right? Integer is my data type, and I know we already know this. And x is my identifier, right? When we create a object of our newly created class, we do the exact same thing. The name of our class is going to be our data type. And then we're just going to create a variable name for our object, right? This is our identifier. And so now we just created a object of car. And so now I can use the dot operator. Right? And the dot operator gives us access to our member functions and member variables. All right, so the way we use our dot operator is we just write our object, right? Since our object is named car, I use the dot, and now it's going to give me access to all of the public member variables and functions, right? These are our member variables. And member functions. So now I could write something called, car.wheels. And then now I can assign how many wheels my car has. And so now my objects, the member variable called wheels now has a value of 4 because I used the dot operator to access that member function and I set it equal to 4. And so why are these called member variables? They're called member variables because if I was to create another vehicle, and let's say I call it a motorcycle, all right? Maybe I'll just call it a bike. All right. When I say, if I want to set, my bike wheels equal to 2, that wheels belongs to bike. It's not going to make any changes to car, right? Each object has its own set of variables, right? These variables are members to this particular object, not to all objects of that class, right? These are member variables. However, what if we did want to have a variable that belongs to both car and bike, or any object that we create a vehicle? Those are called static variables or static functions. And I like to call them class variables and class functions because they don't belong to the object, right? So they're not member functions. They belong to the class, meaning that any object that I create of type vehicle will share the static variable or static function that I create in the class. So let me give an example of that. So let's say I create a static variable, and the way we do that is we call it static. And then let's say I have an integer, and let's say I want to keep inventory of how many vehicles have been created. Right, so I could come here and let's say I create a function. Well, let me not get to that so fast. right? So now I could say car dot inventory equals 1, right? Because car was the first variable that I created. Then I could say, I created bike, so bike inventory plus plus, right? And now if I was to go and see out, if I wanted to see out this, and if I wanted to see out what inventory actually is, right? I could say car, see out car dot inventory, and you would expect me to get 1, right? You would expect me to get 1 because that's what I said it equal to, right? But since inventory belongs to the class and not the object, this will actually return 2. But we actually don't want to access our static variables this way, right? We don't want to access that, right? Because the dot operator says that we want to do it for members, right? So we don't want to do it this way. Since it's a class variable, then we can access this variable by calling the class itself. And we do that by using the class scope resolution operator, right? And so the way we use that is just, we'll say vehicle, and then the class scope resolution operator. This is the scope resolution operator. And we should know this by now. We use that a lot when we use our namespace. And then I just say the variable name. And I can say that equals 10 or whatever. And now if I was to go and see out car, then it will return 2. But remember, again, I said we don't want to do it this way. We don't want to use car.inventory. So what we can do is we can create a function that will return the value of integer of inventory. Right? So what we can do is we can create a function, and these are usually called getters and setters. But this particular one would be a getter. I can say int get inventory. And this right here will return the value, of our static inventory variable. Right, it'll return this value. So I don't want to go too deep into static variables now, but I just wanted to give a mention of how static variables work, and the same would work with a function. We could create a static function, and then we could call the static function the same way by calling using the class scope resolution and then the name of the function. All right, so now that we talked about class scope resolution operator, let's talk about how we define our functions, right? So right now, when we did this here is all of this here is our class declaration. Notice how we're just declaring variables, right? We're just declaring function names, but we actually haven't implemented anything. So the way we implement them is we now define the functions, right? And of course, this would need to be below the declaration. And so we had a function called start engine, right? So we would say void, right? And then we say start engine. However, if we do this, the compiler has no idea that what we're defining here is actually referring to what we declared here, right? Because if you notice, our class is inside a scope, right? So all of these declarations are local to this scope, right? From this curly brace to this curly brace. They're local here. So if I'm trying to refer to those functions outside of the scope, the compiler has no idea where to find them, right? Because those were all local to that class. So the way we tell the compiler to look into that class declaration, we have to use this class scope resolution operator. So we'll say vehicle start engine. And now the compiler knows that whatever we define here is actually referring to what we declared here inside of our class, right? What is declared inside of our class. It's saying go into the scope of vehicle and then find the variable start engine. And that's what this definition is going to define, right? I'm going into my scope of a vehicle and then I'm defining what the start engine function does, right? And so inside here, then we would write our code, right? This would be our code for start engine. Now, let's talk about constructors. The secret word is box. Let's talk about constructors. So now constructors, let's think about when we create a object. I'm trying to think of an object that we use where we actually pass in some value. And I'm not sure if we used any of those yet. But we have seen an integer be declared this way, right? And that means that we're creating this integer and we're setting it equal to 5, right? We're passing in 5 into the parameters in between these parentheses, and then that sets the variable equal to 5. Constructors work the exact same way, right? If I had a vehicle, and let's say that I already know that my car is going to have 4 wheels and 2 doors, then I could declare my car like this, and then it will automatically have wheels and doors set to 4 and 2, right? So I could declare my car like this, 4, 2, and then I could say cout car dot wheels, and this would return 4, and then I could say cout car dot doors, and this would return 2. Right? But that's only if we design a constructor to do that. And basically a constructor is a way that we build our object. Constructors can only be used when declaring and instantiating the operator, right? Can only be used when declaring and instantiating an object. Right? Constructors are the way we build, right? We build and default our object to its default state, right? Sorry about my handwriting. right? So, we created this data type, right? So, of course, the compiler is not going to know that if I pass 4 and 2 to the constructor for car, that is going to automatically set wheels endorsed to those numbers, right? So we have to create that constructor so that it does that, right? And so the way we create a constructor, there's a few rules for constructors. First rule of constructors, and this is a really hard one to grab. First rule is constructors are not, and I'm gonna put that in caps, functions. Even though they look like functions, they are not functions. And I'm gonna show you what a constructor looks like in just a second. Second rule of construction is that they must be the same name as our class. Right, for example, if I have a class named vehicle, then my constructor would be named vehicle as well. Right, that is my constructor. And another rule is constructors can be overloaded as long as they have different signatures. All right, and so let's look at a constructor, right? So let's say we have our class vehicle. Oh, I forgot one last rule. Constructors do not return anything. And since they don't return anything, therefore, they do not have a return type. All right, so let's go ahead and look at how we would declare a constructor inside of our class. So we have our class vehicle, right? And inside class vehicle, we have our public, right? And we normally want to make our constructors public because we use our constructors in main, right? Where did I have that? We use our constructors in main, right? So that means that they need to be public so that we are actually able to access those constructors. Right, so if I'm gonna do a constructor called vehicle, and my vehicle, I want to take an integer for wheels. I'm just gonna call it underscore wheels, and I want to have a variable for doors. I'm gonna call it underscore doors. So that is gonna be my constructor. Now, one thing to note is that there is a constructor called the default constructor, and that looks like this: vehicle, and it has nothing in it. This is default constructor. All right, one thing to remember, if you overload your constructor, then you must also write the default constructor, right? This will be considered overloading, right? This is the default. And the reason why you must write the default constructor is that the compiler automatically writes the default constructor for you, right? So if you make a class that does not have any constructors, it automatically writes this one for you. But once you overload a constructor, then it no longer writes this for you. And the reason why you have to have a default constructor is for cases when, let's say you wanted to make a car lot program inside of your class, right? And so say you wanted to make a car lot, so you want to have vehicle lot, and you want to make it, let's say you have 100 cars inside of your lot. Well, when you do something like this, it is calling the default constructor, right? Because you notice we're not passing any values, any default values to this vehicle array, right? So this uses the default constructor. So it's important, if you ever need to have a constructor that passes parameters, then you always have to also implement the default constructor. If you do not have any constructors, then you don't need to create a default constructor. The compiler will automatically do it for you. So how do we define our constructors? Well, it's very much the same as the example I showed for functions. We need to call the class scope resolution, right, which is vehicle, and then we call the name of our constructor, right? And so I have a vehicle constructor here that took wheels, and I had a vehicle here that took doors, right? And so now I can start accessing my class's member variables, right? And so remember, right here, we said that this function is within the scope of vehicle, right? We are claiming that this is the scope that we're in. So what that means is that any variable that is declared in this scope automatically exists in our functions, right? What I mean by that is that I already declared doors here, right? So let me go back. I already declared doors here. So that means I don't need to re-declare it inside my function. I can actually just go and start using my doors variable, and I can set it equal to the underscore doors that was passed to the constructor, right? And I can do the same thing for wheels and set it equal to underscore wheels. Now, if I was to do something like this, int doors, then it is not going to use my class door member variable. It's going to create a new variable called doors, which is in the scope of this function. And then once this constructor, I said function, once this constructor is done, this door will get deleted by the compiler, and the doors that is actually a member function of this class was never touched, right? So make sure you do not redeclare your member variables, because they will not be the same variable. It will be a different variable, right? So so remember how I said you look at a function at a constructor and they look like functions, right? If you look at it, I'm like, why is this not a function, right? I have a name, I have parameters, right? But what am I missing? I don't have a return value. Notice there's no return value. It doesn't say int vehicle, or it doesn't say void vehicle, right? It just says vehicle. And that is how you can tell when it is a constructor. And so when you say, okay, who cares? Why are you telling me it's not a function? And the reason why I'm telling you it's not a function is because I can't go into int main. Right? I can't go into int main and then create a vehicle car, right? Let's say five wheels. I don't know what a 5-wheel car looks like, but We'll have 5 wheels and 3-door car. I can't later go say, all right, car dot vehicle. Whoops, I made it five wheels. I meant to do it 4 wheels and 2 doors. I can't do that, right? Because this vehicle is not a function, right? It's not a function. And then remember the rules of a constructor. Constructors, where is it? Constructors are ways to build, right? Constructors are ways to build an object to its default state, right? So I only use a constructor when I am declaring, right? I can only use it when declaring and initializing an operator. If I try to do something like this, I already declared and initialized my object. So now that car is declared and initialized, I can't call the constructor again, right? So this is a big fat no. We can't do that, right? Constructors are only here to give you defaults for your object. It's just to get your object set up so that it will work the way you intended. All right, so that is pretty much classes. There's definitely a lot more to classes, but this is going to be as much as we will learn for this particular class. And I hope you enjoyed the video, and please let me know if you have any questions regarding this. Thank you.